Today, we are going to continue with our discussion of percentages. We once again will be using equal fractions to find some answers. In the problems today, we will be given a percent, but this time we will not necessarily be given the number that will match that percent. So we will have to do some subtracting either before or after we use equal fractions in order to get our answers. Let's look at some examples. Example 1 says 45% of the students were going to go away for vacation over the spring break. If there were 160 total students, how many were not going away for spring break? The question is asking how many were not going away for spring break. If we read back up in the problem, we will see the percent given to us is the percent that were going to go away for vacation over the spring break. The other number we are given is the total number of students. When we have a problem like this, where the question is asking for a number that doesn't match up with the percent, we can use the idea that a total percent is 100 to subtract the percent that we're given to find the other percent. Let me show you what I mean. 100% is always a total percent. If we subtract the 45% given to us in the problem from this, which is the number that are going away, what we are left with is the percent that are not going away. Now we do have a percent that matches what we are looking for. So with our equal fractions, we're looking for the number not going away over the total, and that equals up with the percent not going away over 100. We don't know the number not going away. We are given the total in the problem, 160. We have found the percent not going away by subtracting, and we got 55, and that of course is out of 100. We will have to do some simplifying before we can find our answer. In this case, 55 over 100 can be simplified by dividing both our numerator and our denominator by 5, which will give us 11/20. 20 times 8 gives us 160. So 11 times 8 will give us the number of students not going away. So before we could fill in our equal fractions for this problem, we had to subtract with our percentages. Very similar to what we did in lesson 25, only now we are subtracting the percentages instead of the numbers. Let's look at another example. Example 2 says 35% of Alicia's budget is spent on groceries. If she spends $140 on groceries, how much does she not spend on groceries? So we are looking to find the amount that she does not spend on groceries. If we read back into the problem, we see that we are given the percent spent on groceries, and we're also giving the amount spent on groceries. Since the two numbers in the problem, the percent and the number, match, We can use those to find our total, and then use our total with the amount that she spent on groceries to find the other number. So in this case, we are using the number spent on groceries over the total, setting that up equal to the percent spent on groceries over 100. The amount spent on groceries is 140. We don't know the total amount that she spends yet. The percent spent on groceries is 35, and that goes over 100. 35 times 4 is 140. So 100 times 4 tells us the total amount. Now the question was not asking for the total amount of her budget. The question was asked how much was not spent on groceries. Since we now know the total amount she had, and we also know how much she did spend on groceries, we can subtract to find the amount she did not spend on groceries, which would be $260. In this problem, we waited to subtract until the end of the problem, since our percent and our number in the problem matched. Let's look at another example. 60% of the homeworks graded were B or better. If there were 175 homeworks graded, how many were lower than a B? So in the problem, we're looking to find how many were lower than a B. If we read back into the problem, the percent given to us was the percent that were B or better. This does not match with what we're looking for. The number given to us in the problem is the total number of homeworks graded. So this is similar to the first example we saw. If we take 100%, or our total percent, and subtract the 60%, which is the B or better, B and up I'll say, that will give us the percent that is a less than a B. So now I'm trying to find the number lower than B out of the total, equal to the percent less than B over 100. We're looking for the number less than B, so we don't know that. We do know the total from the problem, 175. We found the percent less than B by subtracting and got 40. And that, of course, goes over 100. In this problem, we do need to simplify. 40 over 100. First, I'm going to take a 0 for a 0, meaning I'm dividing both by 10. Since 10 doesn't go into 175, I will simplify further by dividing both by 2 to get 2/5. 5 times 35 is 175. 2 times 35 will give us the number of B's, or I'm sorry, the number less than B, which is 70, scored lower than a B. So again, in this case, we had to subtract our percentages before we could do our equal fractions. Let's look at another example. Example 4. 20% of the students on Team 6-1 wear glasses. If there are 88 students that do not wear glasses, how many students do wear glasses? So the first thing is we are looking for the number of students that wear glasses. We are given the percent that wear glasses. However, the number given to us is the number that do not wear glasses. So this one is actually going to require subtracting twice. What we need to start off with is finding the percent that do not wear glasses, since that's the number given to us in the problem. So we would take our 100% total, subtract the 20% that do wear glasses, to find 80% don't wear glasses. With my equal fraction, since I'm given the number that don't wear glasses, I have to use that to find the total. And then I can use that to get the number that do wear glasses. So the number that don't is 88 out of the total, which we don't know. The percent that don't, which I found from subtracting, is 80 over 100. I'll need to simplify. I'm going to take a 0 for a 0, or in other words, divide both by 10. 8 does go into 88, so I can stop my simplifying process there. 8 times 11 is 88. 10 times 11 will give us our total. Since 10 times 11 is 110, that is our total number of students on Team 1. We weren't looking for the number of students on Team 1, however. We were looking for the number that do wear glasses. So we can take our total, subtract the number that don't wear glasses, and what we will be left with is the number that do wear glasses. And that would be 22. So in the problems we saw today, we may need to subtract our percents prior to doing our equal fractions. We may need to do the work and then subtract to find our answer. Or there's a possibility we need to do both. Subtract our percentages first, do our equal fractions, and then subtract again to find our answer. It's very important that we read what the problem is giving us and use the numbers that match together.